Now we want to go to number 11 of our solution for the Jamb mock. They say the heat required to convert 10 kilogram of ice at minus 5 degrees Celsius to water at 0 degrees Celsius. And what we want to do now is this. Now, this is what minus 5 degrees Celsius. Then this is 0 degrees Celsius. 0 degree Celsius of ice. Then this point, then you now move to what? As you heat it again, don't forget you are plotting temperature against time. Then as you heat it again, you will have what? 0 degrees Celsius of water. Now, within point A to C, what we experience is what we call MC, change in temperature between A to C. Then but between C to what? To D is ml, latitude of fusion. Now don't forget that you change it from 0 degree of ice to 0 degree of water. That means that it's just the heat applied is just to change the state of the matter. You understand? From solid to liquid. And the heat required to change the state of matter without temperature change is what we call latent heat. So that is what changing from C to D. Now the total heat that will not be applied, heat total will not be what? MC, change in temperature, plus ml. So now this C given to us here is specific. This C here is specific heat what capacity of ice. Please take on that. That is specific capacity of ice, and we are given. So let's substitute all our formulas there, because all our values are there. The mass is given. The mass is 10 kilogram. So what else? We are giving C of ice. C of ice is given to us. Then we now substitute. We have what? 10 times what? What is C of ice? The C of ice is 2. We write it, break it down, 2200, 1, 2, 3. Yes, 2200. Then we are also what? Go to check our temperature change. Don't forget the temperature here is 0. So the final temperature is 0 minus initial temperature, because it's coming from here to this place. There is a rise in temperature. That's why we are using this formula. But this one, there is no change in temperature. The change in temperature is equal to 0. And don't forget, when change in temperature is equal to 0, we say the system is in thermal equilibrium. So now, in this case now, minus what? 5 degrees Celsius. So during latent heat, there is equilibrium experienced that is experienced between the solid and liquid phase of water. That means in this case, our water about 10 times. What is our latent heat of what? Of fusion of ice, which is what? 3.3 times 10 to the power 5. So what I want to do now is what? We are going to have, this one will give us plus, so I would have 2,000 times 5 plus this one multiplied by this one, I would have what? 3.3 times 10 to the power 6, because 10 multiplied by 10 to the power 5 is 10 to the power 6. So in that case, we would have this times this, we are going to have what? 0 carry 1. This times this equals 10, 11, so carry 1. 5 times 2 is 10, that is 0 carry 1. Then 5 times 5 is 10, plus 1, 11. Then I want to write that this 30 plus what? 3,3,0,0,0,0, 1, 2, 3, 4, 5, remaining 106. So if you add it together, you are going to have it as what? If you add it together, let's say 11,0,0,0,0,40. So I'm going to have it as what? 3.41 0,0,0,0 as our answer. 341,0,0,0,0. And if you add this one with this one, so which is what? 1, 2, 3, 4, 5, 6. That means 3.41. times 10⁻6 joules of heat. So in that case, what we are going to have is what? 3 point, this one is 6, not minus 6. So the answer is A. It's 6, not minus 6. So the answer is A. 3.41, etc. Now let's go to number 2. And before we go to that number 2, let us have this one wiped off so that we can have enough space for those that are writing that to copy. Now, the next thing is what? They gave us, they say the weight W of a meter rule is what? Now, don't forget that the weight of any uniform object is always at the center. You understand? According to equilibrium. That means if you have a uniform meter rule, the weight of that body or the mass of that body will be at 50 centimeter man. Because meter is 100. Now, we don't need to bother ourselves too much. They've already given us diagram. I think what we just need to do is to find W. Then we take moment about this pivot. So if you take moment about this place, here becomes what? Anti-clockwise. While here becomes what? Clockwise. So we take the first time perpendicular distance. So that I want to say sum of what? Anti-clockwise movement according to the equilibrium, as much remain in equilibrium. It's also sum of what? Clockwise moment. So what is anti-clockwise moment now? 60 Newton. Don't need to convert this to meter. What is perpendicular distance? If you are taking moment, take moment about what? Pivot. So this one now was 60 times. What is distance from here? If this is a force times perpendicular distance, which is 10 centimeter. You see, because so what is the force here? W times what is the perpendicular distance here? 30 cm. So the force times perpendicular distance we are taking moment about the force times perpendicular moment we are taking. And please be careful when you are solving. Now, in the cases of converting, you waste all your time. So in there, no need to convert because all the units here are in Newton. So in that case, what you just need to do is to divide both sides by what? 30 centimeters. And you see clearly that this one will cancel this one what? This one. Then we have got 2. 30 here 1, 30 here 2. So our answer now will not be equal to what? 20 what? Because if you cancel this one now, this one is gone. Then 20 times with this one now got 20 Newton. Do you have 20 Newton here? Yes. And that's how you solve it. So you don't just solve and just solve like that. You must ensure that and if you check from here to here, it's 50. That means this meter is actually uniform. So it's 2.20 Newton as the what? The weight or the mass or the force of the what? Of the meter. This is option what? Option C. Now let's go to the next one, which is what? Diagram. Now the diagram given to us is actually, for what I'm seeing there, should be pressure diagram. When you plot pressure against volume, according to Boyle's law, it says that P is inversely what? Proportional to volume of a fluid. So the volume of a fixed mass of gas is what? Is what produce the pressure that is inversely proportional to what? To what? Volume. Now, if you now relate it, now you notice that this graph is an inverse graph. So it has to do with Boyle's law. And in Boyle's law, what is constant is what? Temperature. There is a constant parameter called temperature. So this one will now be what? K equal to PV. Now, don't forget that K, the physical quantity of K is work done. They can ask an exam. What they mean by physical quantity? That is the SI unit. The physical dimension of this is what? It will give you what? Because Newton per meter square, which is pressure, times meter cube. If you cancel this one, what we are going to have Newton meter, which is work done. But in terms of their constant parameter, according to Boyle's law, this Boyle's law, please. According to Boyle's law, is that this K, the constant there is what? Is temperature normally. And it's not just ordinary temperature, but absolute temperature, Kelvin temperature. Now let's go. So we are going to have P1 V1 equal to what? P2 V2, where you vary the pressure and vary the volume. Now, for what we are seeing in the now P1 is equal to X meter mercury. For what we are seeing here, which has a volume of what? What is the volume? 540 cm cube from here. What is P2? P2 is equal to what? 4.5 meter mercury. Then V2 is what we are seeing here, 746 centimeter. So what we want to do now is for using our formula. P1 is for what is P1? P1 is S times what? V1 is for 540 centimeter cube. You don't need to convert it because our unit is already there. So P2 is what? 4.5 meter mercury times what? 746 centimeter cube. So what I want to do now is to divide both sides by what? 540 centimeter cube. Divide both sides by 540 centimeter cube. Now, if you do that very well, accurately, this one will cancel this one. Now, what we want to have now, after dividing it, should be what? 6 point what? 6 point. This one will give us what? Let's see. This one will cancel this one. When this one cancel this one, 2. Let's say 2 here. We are going to have 2 in 870 to 70. Then 2 here. We would have what? 3 in 17. Then in what? In 6 we would have 3. So by the time you do the division very well, what I want to add of your final answer will be equals to what? If you do that well, I want to have what? 6.216. Press your calculator, millimeter mercury. That's your option C. Option C should be 6.22 meter mercury. I wrote the wrong option because I have the same option, B and C. So it's not supposed to be sure. This one will approximately what? 6.22 meter mercury. That's our answer. That's option C. Now number 14 is theoretical question. Now, but let's see how far it goes. Now, what is this one saying? Number 14. Number 14 is saying that what? That when the phenomenon that occur when whereby the earth is what? And the moon may be placed in what? May be in position where extreme rays and the moon edges intersect before reaching the earth. Now look at that, is explaining what? Annular eclipse. This is the sun. We have the moon. This is the moon. Then we have the earth. This is the earth. So the annular eclipse now. In annular eclipse, the moon, the ray of light that passes through the world, the moon intersects before reaching the earth. Look at it. Look at it. You see? So this one now what? Now something like this. Understand? We have something like this. So we have, this is the moon now. So this one now, this point of it, this is a point of intersection of the world, of the lines, the rays that passes through the edges of the world, of the moon. So when they intersect before reaching the earth, we call it what? The annular what? Eclipse. Don't forget that what? When they do not meet before touching the earth is what we call the solar what? Solar eclipse. Solar eclipse. So that is just that. Solar eclipse is when they do not intersect before reaching the earth. No eclipse of the what? Of the sun. So this one now, another one again they call what? Eclipse of the moon is what we call the, when you put the earth in between. When you put the earth, you understand, when the earth is between the moon and the sun, they call that one lunar. The second one, when it's called lunar what? Eclipse. The lunar eclipse is what? Is when the earth is positioned between the moon and the sun. They call it lunar. But annular eclipse, when the moon is positioned between the earth and the sun, and the ray through the edges of the moon intersect before getting to the earth. And that's what they are talking about here. Annular eclipse. We don't need to waste our time there. Now the number 15, which is the last part of this section, before we continue again, you understand, we'll take a break. Now the instrument used to mark the upper fixed point of an unmarked thermometer is dash. Now there is what we call isometer. Now this isometer works with what? The pressure, the atmospheric pressure. So it works with what? Temperature. That means Anytime they measure the boiling point of the word of a thermometer. So it measure the upper fixed point of the thermometer. Don't forget, constant volume gas thermometer is used to what? To calibrate other thermometers for standardization of other thermometer. Don't forget, hydrometer is used to measure what they call what? Electric density. Then we have our one called hygrometer. Hygrometer is used. Hygro is made from hydro. Hydro for what? Use what? To measure what? Relative humidity using what they call the principle of flotation. So that one is gone. So the answer to that question is what? C, isometer. So that is that. Well, welcome to number 16. It says a man exert the pressure of what? Now the pressure exerted is what? 4.5 times 10 raised to power 5 Newton per meter square. Newton per meter square. Now on the ground has 2.5 times 10 to the power minus 2 meter square of each feet. That means area from the unit is 2.5 times 10 to the power minus 2 Newton what meter square. Now, what did we say we should find? In contact with the ground. What is the weight? Now, the weight we are calculating now, we know that pressure equals to weight over area. Therefore, pressure or weight is equal to what? Pressure times area. So what we're going to have now is what? 4.5 times 10 to the power 5 times area is what? 2.5 times 10 to the power minus 2 meters square. So what we are going to do now is that our answer will be in Newton, because this is Newton per meter square is meter square. So what we have now is this will give us 10 raised to the power 3. Now 45 times 25. Because we will have 5 carry 2. Then this one is 20 plus 10, 30, 32. Carry 3. Then 11. That means I would have 11.25. 4.5 times what? 2.5, 11.25. Now, but what we want to do now is to shift this one a little bit. If we shift it now, our answer will now be what? It's just like when you are shifting it by what? Don't forget, this one now, you are shifting it backwards. So when we shift, we have got 1.125 times 10 raised to the power what? If you are shifting like this, positive, negative, shifting like positive, 4. Now, let me confirm the what? The question very well. Let me check the pressure given to us. Very important. Let's check the pressure given to us so that we will not mess it up. The pressure is very important. Let's give us what? 2 point what? Then we are giving what? Okay, this one is 3. So that we will not be having an answer that is not enough. It's 2 times 4 times 10 raised to the power what? I think this one should be 3. If it's 3 now, that's when we cannot have this one as the answer. So that if it's now 3, so we cannot have it as what? 1. Then if you have 1 now, because 10 raised to the power 3 times 10 raised to the power minus 2 is 10 raised to the power 1. So that when you shift this one, you know, when you have 0.02, if you are shifting like this, it's minus 1. Shifting like this, minus 2. But when you are shifting like this, is what? Plus 1. So if you have plus 1, it will be 10 raised to the power 2 Newton. That will then be your answer. That means if you shift it to put the decimal point here, you are going to have what? That your answer will not be there. Don't forget, 4.5 is what I did times 2.5. But I just did it so that this one is 10 raised to the power minus 1, is 45. 10 raised to the power minus 1 is 45. So I shift decimal point twice, 1, 2. That's why I get that amount. So that is just that. That is option what? A. So please take note, correct this particular pressure. If it's 10 to the power 5, it will now be 4, because we don't have it in the option. Now, Newton's law of Pauli is valid for what? Dash. Now, Newton's law of cooling states that the rate of what? Of heat is directly, the rate of heat is directly what? Proportional to the difference to the difference in temperature between what? Temperature of the object and its surrounding. So this is what he actually stated. He says what? He states that what? The rate of each what is directly, each flow is directly what? Proportional to the what? To the difference in temperature of the object and its surrounding. Now don't forget that what? It is what? Valid for what? Small what? Temperature difference. It is valid for what? Small temperature difference. So when the temperature difference is small, it will allow, it will disorganize, or let me say it will disapprove what? The shift in what? In equilibrium. So because what this thing is actually trying to do is what? To balance the equilibrium between the temperature of the object and the temperature of the surrounding, so that heat that is lost from the object will be going to the surrounding, and heat can also be absorbed from the body or from the body to the surrounding. So now it is not what? It is not valid for what? Large what? Temperature difference. Please take on that, because it will shift the equilibrium. It shifts the equilibrium displacement. Large temperature difference. It is not valid for what? Large temperature what? Difference. So please take note of that. So in free flow of heat, no, heat is not free to move because it's in a closure. There is a body and there is a surrounding. So the heat that is lost from the body is going to the surrounding. So there is not, we cannot say it's free flow of heat. But when they say pressure of heat source, no. Large temperature range, no. Small what? Temperature what? Range. I think I will go for what? D for the answer. Small temperature range. Now let's go to what? This one is what? We have a plus 10 column, what, having a distance of 3 meters from x, measure from 3 meters from x. They give us 1/4 pi permittivity as what? 9 times 10⁹ Newton meters square per column. Now what did they say we should find? They say we should find the electric field. The question says find the what? Find the what? The electric field from S. They say we should find the electric field from S. That's what the question says. Let's confirm it. It says what? They say we should what? Let's see. They draw a diagram. They say find the electric field strength at X. Okay, at X. Find the electric field strength at X. So we are looking for electric field at X. Now we want to do that quickly. Let me quickly erase this one. Quickly. Let's do that fast. Electric field at X. Now, if we are looking for electric field at X, now what we are going to do in that is what? Electric field is equals to K over R square. So where what K is given as what? 9 times 10⁹ Newton meters square per column. Then we have what? Per column, then square. Then we have what again? We are given what? R is equal to 3 meters. They are given distance from here to this for the X, from X. Then what again? I will give you. Charge is given as what? Plus 10 column. Then what again? I will give you. Nothing again. So we are looking for E unknown. So E becomes what? 9 times 10 to the power of 9 times what? What's our Q? 10 divided by what? By R square. 3 times 3 is R square. So this one will cancel this one. I will have 10⁹ plus 10⁹ plus 1 will give us what? 10⁻10 according to indices, because you don't have calculator in the exam that will do this one for you. This exam calculator can never solve this one for you. Volt per meter. Don't forget what that E is equal to voltage, potential difference over D. E equal to force over charge. E can be equal to force over charge. E is equals to what? K cubed over R square. E equal to K cubed over R square. E is equal to work over what? QV. Work over QV. Don't forget that what QV is equal to work. So, and this one is what? EG. So that means QV equal to what? Then V is equal to EG. So that means Q times distance. So please take note of this word, the formula for electric field. Very, very important. Now let's go to number 19. Number 19, you don't need to solve. Reason be that they said a progressive wave equation is given by this equation. Now they say if T and M and X are in seconds and meter respectively, determine the what? The amplitude of the wave. To determine the amplitude, just what? This is it. Amplitude is what? Because if you compare wave equation, understand that the wave equation now, if you compare them with what? The standard formula is a y equals to a sine what? Omega t minus what? Ks. That is a formula for wave equation. So now, if you compare it, this amplitude, this angular velocity, this wave number, this is what? Displacement, path distance, this time, this is what? Displacement along, and this amplitude. So if you compare them, y equals to 0.9 sine what? On 200 what? T minus what? 0.6 s. Anytime you have a minus here, notice that the wave is traveling towards the what? The positive what? X direction. Anytime you have plus, you know it's traveling towards negative X direction. So the middle can be plus, traveling positive X direction, minus, traveling towards what? Minus is traveling towards positive X direction. If it's plus, traveling towards negative X direction. So now that is amplitude is equal to what? C. But listen and listen so good. If they ask you for what? Phase velocity or wave velocity is equal to omega over k. Let me drop this formula. Apart from what you know as frequency times lambda. So W divided by what? Angular velocity divided by wave number. Don't forget, angular velocity is equal to 2 pi f. Then k is equal to 2 pi over lambda. If you divide this one by this one, you are able to have this one. So you can just solve and say 200, which is W. If you compare them, they ask you divide by what? What is k? 0.6. And at the end of the day, you are now going to be having 2000 divided by 6, which is 333.3. So that's what you are going to get meter per second. But instead of you to now be doing long method in your secondary school method and all that, your basic, just go straight. This one, pick this one. The coefficient of t divided by what? Coefficient of x. You are going to have your what? Your phase velocity. Instead of you solving for frequency first, compare, like solve for your wavelength and all that before you now know time as well. Now let's go. The last one there for this section again is that it says two forces forming a couple. Two forces forming a couple. It says are separated by a distance. They are separated by a distance of what? What is the distance of separation? They are separated by a distance of 0.25. Now that means that two couple is a couple, one is here, one is here. They are separated by a distance of 0.25 meter. So this is one of the forces, one of the forces. There must be equal forces, not parallel, but not acting along the same line of what? Action. They are acting opposite, equal in magnitude. Now what they say we find, if one of the forces is 40 Newton, one of the forces is 40 Newton, what is the moment? So this moment of a couple is called torque. The moment of a couple is called torque, which is what? One of the force times the distance. So one of the force times the distance. So what we are going to have is what? We are going to have it as 40 times what? 25 divided by what? 100. So this one will now give us what? Because 25 times 100 is 1000. 1000 divided by what? 100, you are going to have 10 Newton meter. So if you check your option, I want to have what? Option B is the answer, 10 Newton meter. I think we are going to continue again in the next section. Thank you.